Computing hyperbolic utility parameters. Our video on the polynomial factoring problem introduced hyperbolic descriptions of technical and household indifference. Hyperbolic production and utility parameters have our favor. 1. Because they enable a closed-form solution to the polynomial factoring problem, and 2. Because they easily support SF-Econ's notion of efficient prices as a consensus of current values for marginal products. Hyperbolic production parameters can be visualized as the vector offset between a production function's origin and the natural origin of the hyperbolic form, that origin being natural in the sense of being the intersection of all the function's asymptotes. Hyperbolic utility parameters, z and u sub j, are determined by knowledge of one point on the indifferent surface, y and e sub j, that is known to be optimal in respect to current prices, pi and p sub j, pi being the price of the good being produced, and p sub j being prices of the productive factors j. These variables are summarized here, next to the compact form of the equation for hyperbolic production functions. This equation has optimal values for the output xi and for the inputs q sub j, replacing the variables y and e sub j. In the analysis to follow, we will presume knowledge of one such point on an otherwise uncalibrated production function, where that point is accepted as optimal with respect to a known vector of prices, pi and p sub j. Our task will be to describe that production function in terms of z and u sub j, such that xi and q sub j are on the indifferent surface, and the curvature of that surface in every coordinate direction j has its gradient equaling a ratio of p sub j to pi. In other words, if we observe the operating decisions that a sector is making with respect to a given price environment, what would be the shape of its underlying technical trade-offs according to marginalist criteria for economic decision-making? No one has, as yet, offered a closed-form solution to this problem. While we have our suspicions that such a solution is possible, we are currently making do with the algorithmic solution embedded in the spreadsheet we will be describing here. Links in the show notes will take you to papers that develop the mathematics used in these algorithms. The front-end spreadsheet for our utility algorithms is showing here. Column C provides space for entering the names for the output and for the input commodities. These names can be removed en masse by clicking on the Clear Names button. Commodity names are optional and are available to be used as needed for presentation purposes. They have no effect on what the algorithms do. Alternately, inputs can be referenced by number as automatically provided in column F. The data actually used by the algorithms are entered in columns D and E. Row 8 records entries for the output's price pi and for its rate of output xi. Rows 11 onwards records the entries for the input rates j and their prices. Blank rows are permitted in the sequence of inputs. Column G will receive the algorithm's computations of the utility parameters j. These results can be cleared away en masse by clicking on the Clear Parameters button. Computation of utility parameters requires input of a code that informs the algorithm as to the type of sector being calibrated. 4 types of sectors are recognized. I indicates a generic profit-making industrial sector, for which ordinary notions of input, price, product, and price of good being produced are self-evident. H indicates a household sector. Data entered for households must conform to SF-Econ's peculiar notions of how households are to be described. The price to be entered for a household sector is its wage rate, but the output rate is the household's consumption of leisure time, which is recorded at the intersection of a household's row and column in the input-output structure. A household's consumption of its own product is not to be entered among the inputs for which utility parameters are to be computed. If, for example, a middle-class doctor employs the services of a middle-class lawyer, he is considered to be interacting with whatever sector dispenses legal services, not with his own middle-class household sector. If a sector represents a dependent population, which does not produce a saleable product, then its output and the wage are to be left blank. A code of G is used to indicate a government sector. Entries for a government sector's output quantity and the output price are to be left blank. For our purposes in computing utility parameters, government sectors are fully described by the list of their input quanta and the input's prices. A code of F indicates a financial intermediary. SF-Econ's handling of these sectors does not recognize their product as quantifiable in terms of a calculable marginal cost of production. Hence their output quantity and the output price are to be left blank. Financial intermediaries, like governments and dependent populations, are described entirely by the list of their input quanta and the input's prices. Once a sector's type is recorded, along with its input-output data and respective prices for these physical quanta, a click on the Compute Utility button will quickly compute and present the sector's utility parameters along with some parameters used in the calculations. A variable eta counts the degrees of curvature in the sector's production function. The sector's z parameter will be presented, along with the sector's highly descriptive zeta parameter.